Hello and welcome to Honest Science Tube. This is a broken motor of a broken blender, and I like to see if this motor could be used as a generator. This is the motor. It is still turning. Maybe you see those small parts moving. And this is a digital multimeter. I will use this configuration because as a motor, this operated in the standard European electricity system with 220 volts and 60 hertz. So I expected as a generator to essentially bring the same parameters, but I don't know if this thing is even working properly. There are two small copper wires, or it could be a copper alloy, but it just looks so nice and reddish. I think it's a copper wire. They're looking so good, I basically turn them around those testing things. Not too fast, but for establishing contact with it. Ooh, that came off. It should be here. I don't know why. No. Let's see the voltage. It would be. Could you see? Yeah. I think it would be good for using the highest input possible here for the voltage, and it is alternating current. Oh, that pull came off. I will turn just this and see if there is something. Nope. Apparently not. No potential difference between those 2 points. There shouldn't be any electric current going. Yeah, also not. That settles this. Hello, past me. I'm from the future, and I'm much smarter than you. Actually, while editing the video, I noticed that it is impossible to produce any current between those two loops of copper wire because they are not electrically connected. Yeah. Honest Science Tube guy. Bye, past me. Okay, this thing apparently does not produce any electricity if I turn it. This is unfortunate, but why is that the case? Let's take this apart. Apparently, I need a screwdriver. Those two screws look promising. I think they're holding those metal frames in place and these very huge iron or steel frames. Oh, there's actually the indication telling us how powerful this motor would be. Like a sure sign of getting old, you need an electric screwdriver. Wow, here we go. Okay, now this is apparently free. It could be the case, but this is just a quick thought of mine that those here is a black plastic thing, and this motor essentially broke by overheating, and that could have molded the plastic just a bit to adhere to the metal. So, but it's just theory, I don't know. It's not even theory, it's a thesis. Okay. Wow. Okay, very important. Don't just screw off blindly anything. Make sure you keep it somewhere where you could find it again. And I like pottery. Now there's some action outside. Okay, now those things should come off easily. You see, I can move those two parts, but it's actually not doing anything else. Ah, this came off. Okay. Ooh, interesting. There are some metal parts. This is actually a bit lubed to reduce friction. Those are here as well. Essentially, now we can say that we know already why this is not producing any electricity if I just turn it that way. It is because there is apparently no permanent magnet inside it. Normally you have a stator, which is not moving, and a rotor, which is moving. This is the rotor here, quite obvious. And one of the two parts is sometimes, in generators, a permanent magnet, which produces a magnetic field, and as you know, or should know, moving electrically charged particles in an electric field is producing a current. Okay, this is coming off right now, and we see that it is here wired, so I put it back and try to remove the wiring. Oh no, it is actually, it's a bit molded together. You can see here there's been applied some, no, it's not welded, it's put together, and I have to apparently I have to destroy it. It's now this is coming off clean. Here we have the starter again, or in this case the starter of the motor. You see those two huge and bulky windings. And this does not come on off any further. This is the rotor unit, rotates nicely, and the really interesting thing is this one here on the top. As you can see, those copper wires, or those copper wires, bring electricity from one of those into here, and actually are in contact with tiny, does this camera focus it? Kind of, to those tiny plates, and those tiny plates are in contact, this is really hard to see, in contact with copper wires that actually turn out to run in circuits like so, and basically I think they basically taken part of doing they're basically electrifying these small plates here, and by doing so they produce a magnetic field, and that magnetic field actually should then be interacting with the magnetic field producing by this copper wire loops, and those electric fields either repel or attract those two things, and then it rotates. But this is only happening if there is an alternating current coming to those two copper wires. So it is quite clear that this will not work by just bringing electricity back. But here's the question: should it be the case that if I bring on it a very mild potential difference, and in that way producing a small current and producing a small magnetic field here, which is then interacting by moving the rotor with those coils and producing electric current? Interesting question. It's just ad hoc. I do not have done any calculation because I'm a lazy bastard. But yeah, let's put this together and see if I can find a mild source of electricity. I already got one. This is a small battery. If not, hopefully I do not come in any trouble to wavering around this. This is fun. I move it fast enough you can't read it. Okay, let's read the description. It should produce a potential difference of 1.2 volts and a minimal capacity of 2,400 milliampere hours, it states here. Okay, this is a typical for those AA batteries. It's rechargeable. I like those. I use it in my bike illumination. Do I say this bike illumination? It's bullshit. No, it's fine. Okay. Good. Let's see. I think I will at first have a look. What I like to do now is to put it all together again. Hopefully I knew the correct sequence of putting this on. Oh, that goes nice. And this. Oh, there. Oh, no. There are. Shit. Okay. This one first. And this one. No, the other way around. This one. This one. Then this one and this one. Yeah, that looks good. Ooh, scary things happening. Okay, let's put the screws back here. I will not apply too much force on the screws. This could be not that good. Okay, let's see. Oh, what we have here? This, I think, there's no marking on it, but I think this is a resistance. Oh, there's very tiny writing on it. Oh shit, this is so tiny. Fucking hell. What is it? JY332M? Does that state the same? Yeah. But it does not say, so, or at least I can't cipher it. It's +5. I mean, it could serve the purpose of insulating the casing from the electric current going through here, because yeah, then this will actually not work that way. Let's see. Okay. Wrong again, past me. This is not a resistor, it is a capacitor, and it is a special high voltage capacitor, and what it does in this configuration I explain not in this video because I need content. Content is very important. Capacitor, not resistor. Capacitor. I do not need a screwdriver for the moment. I need my wonderful digital multimeter back. At first, let's see if the battery has still some juice in it. Voltage, this is now, no, direct current, because this actually, the battery actually do not produce. Okay. Well, let's just put it on the tip and yay! Yeah, come on. Yay, also. It's essentially a bit more than the 1.2 volts. Don't know. Maybe this is a supercharged battery. Don't care. Good. At first I like to this does not come off. So at first I like to actually make a current between those 2 points. By the way, those are very, very small currents and very small electric potential differences. So it is essentially not harmful to humans. It would be insane do not touch huge acid lead batteries, but those one is perfectly safe. Where is my hair? Okay. So this is a very nice tape, and with that tape I will just fix the oh, it's actually the same tape blocking out the light from my camera from those videos I never actually got finished. Shame on me. They're not off the table, by the way, but I have a lack of programming inspiration, let's put it that way. Yeah, that could just be the right spot. Come around here. Oh, no sparks, no nothing. Okay. Okay, as soon as I connect those two, there must be a current immediately, because there is no switch between it. And so I like to leave this a bit short. Only a short period of time, and remove it immediately, because I really want to know what's going on between those here. Okay, nothing. Nothing, it's dead. Oh, no life in it. No life in it, guy. No life. Sad. Turns out I could essentially do nothing with it. Okay, there's another, could be another thing that I just could not hit properly the pole of the battery. But I'm pretty sure there's contact. Let's try it again. It should be here, it should be here. No. Whoa, look at this. There it is. Oh, you saw it, I just turned the wheel there. Ah, okay, we have officially a potential difference here. Wow. Sometimes it's not magic. Maybe there was a a position of those small metal plates I showed you earlier that was not closing the the loop. Okay, I don't know if you see this very well. I will place it that way. I touched those small metal wires, and subsequently, as far as I go out to the contacts, you don't see it, I screwed up. Here we go. And I basically took the potential difference between the individual plates, and it grows subsequently, and this is the most I can get. This is about 1 volt. It's basically nothing. But here's the point I tried to make. If there is a potential difference, there should be an electric current too. And let's see if this is the case. I start very generously at 10 amperes. No, at 200 milliamperes, because it is not fused that way. And let's see if this is go. Ooh, yeah, absolutely. 200 milliamperes. We have a current of 100 milliamperes, and here up to 80 milliamperes. It should be a bit different, so there is definitely a current running in the rotor copper wires. In which way, I actually don't know, because this is so convoluted, but there is running definitely a current round and round and round. And as I turn it, oh, this is hard to turn actually. I think I screwed it a bit too tight. If I turn it, I should be measuring a current in the outer copper wires, and since I do not think I have to here, this is one loop, and I will put the one around here and the other one around here, and if the starter is steady, there shouldn't be any current, and if the starter is running, then you basically have a magnetic field altering in this here, and it should produce a current. This does not. Maybe it's too weak to detect. No, this is also not functioning. No current here. No, can't detect any current. But maybe I can detect a potential difference. Also not possible. Okay. Let's cut the connection. Poor battery. Must do such hard work. Have a rest. Okay. So I've managed to produce a potential difference and an electric current in the rotor unit, but this does not result in an electric current or an electric potential difference at the starter copper wires. Well, What's if the other way around is working? Take one copper wire? Nah, there's short circuiting. This is not, I think this wouldn't work either. I think that the problem is, as you see here, those copper wires are not, they're basically short circuiting everywhere. So I just took the potential difference and the electric current from here to here and a bit around those, but this does not say anything because it could just run from straight that way, and this does apparently not produce any current or in the magnetic fields here at the rotor copper wires. Sad. But this is really just a motor. Just the motors. I think it can't be used as a generator. Well, thanks for watching. Until next time, bye.